This video will cover a real-life problem involving compound interest. The problem reads: Claire has just sold 100 gallons of lemonade after spending a week in downtown Disney. She has made $3,000 and decides to put it in a 9-month CD that yields 6% interest. How much money will she have at the end of the term if it is compounded daily, weekly, monthly, quarterly, semi-annually, or annually? We're going to have 6 answers for that. B. How much money will she have at the end of the term if it is compounded continuously? C. How long must she leave the money in the account if she wants $3,500? And D. What interest rate does she need to look for if she wants $4,000 in her account by the end of 7 years to take a nice vacation? So, first we do A, and it's asking us for a certain amount of times it is compounded, which is n, and the only equation that involves that variable is the compound interest one, which is A, our current amount of money, equals P, the principal amount, times 1 plus R over N, the rate over the number of times it's compounded, to the to the NT. And T obviously stands for time. So let's identify what we have. We don't have A, which is what we're looking for. P, the principal amount is $3,000. R is 6% or 0.06. And we don't know. And T is 9 months or 0.75, because when we put 9 over 12, the decimal form is 0.75. So now we can plug in what we have and answer the problem. Since I said we're going to have 6 answers for that, I mean because it's asking us for specifics. So 365 is daily, and so on. So now we're going to plug this into our calculator. Press graph. And to get the values, we're just going to press trace and plug everything in. So first is 365. And we get $3,138.07. We plug in 52. And we get $3,138.00. Plug in 12. And we get $3,137.73. We plug in 4. And we get $3,137.04. We plug in 2. We get $3,136.01. We plug in 1. And we get $3,134.01. So that's basically what A is asking us for. Now we want to answer B. He's asking how much money will she have at the end of the term if it is compounded continuously. Now, when we compound continuously, we're going to use a different equation because it's not a specific number of times, and the equation is A equals P, which is the principal amount, times E. E is not a variable, actually, it's a number, to the RT, which is a rate in the time. So let's find out what we have for right now. We don't have our A, but we have P, our principal, which is $3,000, our rate, and our time. So now let's put it into the equation. A equals $3,000 times E to the RT, or 0.06 times 0.75. So now let's calculate this. $3,000 times E to the 0.06 times 0.75, and we get $3,138.08. So that's what B is asking that for. Now we move on to C. She's asking how long must she leave the money in the account if she wants $3,500. Now in this case we don't have our time, so that's going to be missing, but we do have our current money, which is A. So it'd be $3,500 equals 3,000 times E to the rate times time, which is 0.06, and since we don't know the time, we're just going to leave it as X. We can divide both sides by 3,000. And I like working in fractions because if we get a decimal, then we're rounding it and we're kind of changing what it really is. So this as a fraction is actually just 7/6. Shocking, huh? Equals E to the 0.606, X. We're going to take the natural log of both sides since E is involved. And we're going to bring this 0.06x to the front. So ln 7/6 equals 0.06x times ln of E. Ln and E are inverses, so number one, when we calculate it, we get 1 and they cancel each other out. So now that we just want to look for x, so we can divide by 0.06. And when we do that, ln of 7/6 equals divided by 0.06. We get 2.57. Now we can't round, or we can't just keep it as 2 years, because that we still need that 0.57 portion to get what we need. So what we do is we make a proportion. 57 is in the 100 spots, So 57 over 100 equals how many months in 1 year, which is 12 months. So we cross multiply 100x equals 684 divided by 100, and x equals 6.84. Now we have a decimal again, so we're just going to actually round up, and this becomes 7 months. So she's asking how long must she leave the money in the account if she wants $3,500, and the answer is 2 years and 7 months. And now lastly, D. D's asking what interest rate does she need to look for if she wants $4,000 in her account by the end of 7 years. So we use the same equation, except instead of us not having R this time, not having T, we don't have R. So we solve in the same way, but we're solving for a different variable. So it'd be $4,000 equals 3,000 times e to the RT, which we don't have the rate, but the time is 7 years, so 7, and we're gonna keep R, which is what we're trying to find out, as x. We divide by 3,000, and we get 4 over 3 equals e to the 7x. We ln both sides, take the natural log. We move this 7x to the front, so ln 4 over 3 equals ln 7x ln of e. Now ln of e, ln and e cancel each other, so that becomes 1 because they're inverses. So we just divide by 7, and when we calculate that, we get x equals 0.0411. Now this is correct, but as a rate it needs to be in percent, so we move it over 2 decimal places, and this becomes 4.11%. And that's it.